So, good morning, all of you. This is Ankita. I'm working as an assistant professor in Jil Bajaj Institute of Technology and Management. I will be explaining today the topic operational amplifiers, the IC that is used to make op-amp is IC 741 generally. My learning outcomes for this topic will be the students will be able to understand the basic concepts of op-amp and its various applications. They can develop skills to design simple circuits using op-amp. They can be able to solve problems related to it. So, what do you understand from op-amp? Basically, op-amp is made up of two words, operational and amplifier. Operational means this electronic device can perform mathematical operations like addition, subtraction, integration, differentiation. Amplifies the signal means it can amplify both DC as well as AC signal simultaneously. Op amps can be known as buffer also in general term. It can be known as amplifier. It is symbolically represented by a triangle having mainly 5 pins, 2 inverting, 2 input pins, 1 inverting, 1 non-inverting, 1 output pin and 2 supply pins, which can be seen in the diagram. So, this 7th and 4th pin is known as dual rail pin input, which can be made with the help of different type of circuit, which will be explained further in this demo. Second thing is we are having two input pins. The second number pin is the inverting pin and the third number pin is a non-inverting pin. The sixth pin is the output pin. Pin number 1 and pin number 5 are known as offset null. The offset null pin helps to maintain the output voltage equal to 0 if the difference of the input voltage is 0. Since we all know that op-amp works on the concept of difference amplifier or difference input, the output always we get with respect to difference of the input. So, if in any case the input is given to be 0, the output should always be 0, but due to some leakage current or instability in the circuit, the output ideally doesn't comes to be 0. So, to make the output practically 0, we used to connect a potentiometer in between pin number 1 and pin number 5, which can be done like this. Suppose you have pin number 1 and here you have pin number 5. Here you connect potentiometer that will maintain the output voltage equal to 0. Hence, the pin number 1 and pin number 5 is known as offset null. The one very important thing to be noted, or you can say it is the disadvantage of this IC 741, is its slew rate is very low. So, it is not preferred for the high frequency electronic devices. Now, the characteristic of an ideal op-amp. The gain of the input, the gain of the op-amp is always infinite. The input resistance is infinite. The output resistance is infinite ideally. The bandwidth should be infinite ideally, and the slew rate should be limited to 0.5 to 20 volt per microsecond. Ideally, the slew rate should be infinite. Now, what is open loop op-amp and how does its equivalent circuit looks like? So here we can see that the internal op-amp formula is given by V output should be given by A, that is the gain of the amplifier, and difference of the voltages V2 minus V1, or in general we can write A into Vd equals to V0. So the gain of an practical op-amp should be around 2 lakh or 2 into 10 to power 5. This makes this device practically usable in any kind of circuit. So a small example of op-amp can be a computer, a calculator, a CRO that we use in the laboratories of electronics, anything that can be used for amplification purpose and to do mathematical operations also. Next thing is the equivalent circuit. So here, how does this equivalent circuit looks like? We are giving a input resistance to the circuit, that is known as Z in. We are getting a output where you can see there is a voltage dependent voltage source. How this voltage dependent voltage source is connected here? We are having V input at the input terminal. Every op-amp has a gain that is known as open loop gain AV. If we multiply it with the input voltage, the output voltage will always be increased. In this manner, the output of a op-amp or open loop op-amp is calculated, and this is how an op-amp can be used to amplify a input signal. Now moving to the next slide. How does a inverting amplifier works? So here this is the application of op-amp, first application of op-amp, that is the inverting amplifier. You can see the circuit drawn here. You can calculate the gain from this circuit by using virtual ground concept and KCL or Kirchhoff's current law. So here suppose we are giving input current I in. By the formula of voltage ground concept, by this concept, voltage ground concept, we know that potential of this point is equal to potential of this point. So if this potential is grounded or 0, it means this point having potential equal to 0, and we can write I is equal to IF. The IF current is running across this terminal, that is the feedback terminal. So IF can be given by V in by R1. So current through R1 terminal is given by IF is equal to V in by R1. Current doesn't flow into the op-amp, one of our rules, because ideally the input resistance is always infinity. So the current through R1 must go through R2. Voltage drop, now to calculate voltage drop across R2, we can write IF R2 equals to V in equals to R2 by R1. Or we can use the formula I is equal to IF. I in is given by V in by R1 equals to IF. IF can be given by V naught upon R2. V naught minus VB. Here VB is 0 due to voltage ground concept. So from this formula we can calculate that V naught upon V naught upon Vi equals to minus R2 by R1. So the gain is given by minus R2 by R1. This negative sign shown here is earning because of the inverting amplifier. Now moving towards the next slide. There is non-inverting amplifier. I am attaching a explanation video with this PPT also. This non-inverting amplifier, as the name suggests, tells you that the supply is connected to the positive terminal of the op-amp and the negative terminal of the op-amp is grounded. By virtual ground concept, we can tell that the potential at this point A is equal to the potential at this point B. There is a feedback network coming from the output terminal to the input wire. Why we are using closed loop here? Because using a feedback network increases the stability of the circuit. If you give a input signal or any input voltage at the input end, you will be getting a non-inverting output at the output terminal, which can be seen here with the waveform of the circuit. As the wave changing from 0 towards 180-degree phase out, in the same manner we are getting the output. At the highest value, at the peak value, the output is also maximum, and at the negative end or negative peak, the output of the waveform is negative. So we can conclude that an inverting amplifier gives us an output waveform that is 180-degree having 180-degree phase shift, but a non-inverting amplifier gives an output voltage that has 0-degree phase shift as compared to input voltage.